Good afternoon, everyone. Welcome to our Physical Science online learning. So, class, we are on our seventh week for the fourth quarter. So, we still have one more week left. Right. Now, student, I want you to check this out. So, I prepared few pictures. So, I hope you have to take a look at this. Then, tell me about the pictures as you can see on the slide. Okay, you have there. Okay, so what did you think is that? Another picture. And another one. So as you can see, it moves. And we have the last one. So these are the things that we are going to learn today. So we are going to discuss all about this. So what do you think will be our lesson for today, class? Yes, exactly. You are correct. Our lesson for today is all about radio waves. So this pictures being shown has something to do with our lesson for today. So, students, did you know that I am always excited to be with you and be a part of your journey in exploring the wonder of science world. So I'm teacher Evelyn, joining with you today with the science world of the radio waves. Okay? But before we'll begin, let me check first if you are ready. So, do you have your pen and notebook? And of course, the learning modules with you? Okay, that's great, class. So, let's get started. Our learning objective for today's lesson is describe how Hertz produces radio pulses. So before we proceed with our main topic for this lesson, which is how Heinrich Hertz produce radio waves or pulses. So let us first give a quick glimpse to one of the important discussion that we will connect our main lesson, which is the theory of electromagnetism. So this is by James Clerk Maxwell. Electromagnetism as a division of physics that is concerned with the study of the interacting relationship of electric currents or field and magnetic fields. Now, who is Heinrich Rudolph Hertz? Heinrich Rudolph Hertz was a German physicist who first conclusively proved the existence of the electromagnetic waves predicted by James Clerk Maxwell's equations of electromagnetism. So the unit of frequency cycle per second was named the Hertz in his honor. Okay? Now, the theory of electromagnetism by James Clerk Maxwell. So in his formulation of electromagnetism, Maxwell described light as a propagating wave of electric and magnetic fields. So more generally, he predicted the existence of electromagnetic radiation, coupled electric and magnetic fields traveling as waves at a speed equal to the known speed of light. Now, this is James Clerk Maxwell. So, the image of James Clerk Maxwell. So, he is a Scottish physicist who proposed the theory about the relation of electric currents or fields and magnetic fields, and that was in 1873. So, he developed the unified theory of electromagnetism. So, what is electromagnetism? So, as you know, it is defined as electromagnetism as a subdivision of physics that is concerned with the study of interacting relationship of electric current or fields and magnetic fields. So we have here the four main interactions of electromagnetic forces. So first is the force of attraction or repulsion between electric charges is inversely proportional to the square of the distance between them. Magnetic poles come in pairs that attract and repel each other as much as the electric charges do. And number three, an electric current in a wire produces a magnetic field whose direction depends on the direction of the current. Now, number four, a moving electric field produces a magnetic field and vice versa. Okay, class? So these are the main four interactions of electromagnetic forces. Now, we have here the diagram for the electric field and magnetic field. So this figure shows the interaction between the magnetic field and the electric field and the light. Okay. So we have here the table of the electromagnetic spectrum. So as you can see, so please follow the table. You have here the name of wave, which is the radio waves, microwave, this the infrared, and the visible region. You have the ultraviolet, the X-rays, and the gamma rays. So it is also written here their respective wavelength. So try to follow the wavelengths for the radio waves, and you also have the size comparison and the frequency. Okay? So for the visible region, you can see the color red, orange, yellow, the green, the blue, indigo, and the violet wavelength. So this is the color in which you can see. Okay? Now, what are radio waves? So radio waves are electromagnetic waves. It is measured to have the longest wavelength in the electromagnetic spectrum. So its frequency ranges from 300 gigahertz to as low as 300 kilohertz. So radio waves or radio pulses are also considered to be one of the most important discoveries the human has ever had because it made communication more efficient. So see, how was it produced? Heinrich Hertz verified the existence of radio waves or pulses in the late 1880s. In 1879, the 22-year-old Hertz was seriously thinking to prove Maxwell theory of electromagnetism as part of his studies in Berlin. So by 1886, while continuing his quest to verify the theory of Maxwell, he witnessed an electrical spark in one of his devices. So that spark directed him to deep thoughts and questions. Okay, this figure 2, the conceptual design of Hertz spark gap transmitter. So what did Hertz do is Hertz put up his spark gap transmitter. So as he was already experimenting to prove Maxwell theory, he hoped that his electrical apparatus would transmit electromagnetic waves. So what he did at both ends of his spark gap transmitter, Hertz put two hollow spheres of 30 centimeter diameter with 3 meter apart. Okay, so these spheres acted as capacitor. Okay, so try to look at the diagram or the illustration on the slide. So capacitor, this is a passive electronic component with two terminals and stores electrical energy in an electric field. Okay, so as he was using his transmitter in front of his students, he then applied a high voltage alternating current electricity across the central spark gap. So it produced electrical spark through a process called magnetic induction. Okay? So the sparks flew between spark gaps, small gaps in the circuit. So he started producing them using a piece of electrical equipment called the induction coil. So the induction coil converted low voltage direct current electricity from a battery into a high voltage alternating current electricity. So the electricity crossed a small air gap at consistent intervals as a spark. Okay? So Hertz observed that sparks cause an aggressive pulse of electric current within the copper wires leading out to his or to the spheres. So these uncertain electric charges produce electromagnetic waves or radio waves. So the radio waves spread out at the speed of light in the air around the or light through the air around the wire. Okay, so this is the explanation of the conceptual design of Hertz spark gap transmitter. Okay, so to sum it up, radio waves are a type of electromagnetic radiation best known to be the use in communication technology such as television, mobile phones, and radios. So these devices receive radio waves and convert them to mechanical vibration in the speaker to create sound waves. Okay? So these waves are pockets of energy with differing wavelengths. So similar to the visible light waves, the X-ray or gamma rays exert longer a radio wave like the other electromagnetic waves. So it's similar to an ocean wave or any other type of wave. So both of waves have a hill and valley shape repeating over and over. Okay? Okay, so we are on our last slide. So, class, thank you for joining me in this online learning discussion. So, thank you. Oh, before I forget. So, again, after this, please go over with our learning path, and I want you to answer the quizzes and of course the activities. So class, do not forget to submit that online before before Friday as much as possible. And again, thank you, and God bless us all.